Hello dear friends, today I am going to discuss about the steps to draw displacement diagram for different types of follower motions. First, we will discuss about what is the follower motion. In the cam follower system or the cam follower systems are designed to achieve a desired motion to the follower, that is here, the desired motion to the follower. Appropriate displacement patterns are to be selected for the purpose. For this purpose, so before designing the cam, the displacement pattern, that is which type of the follower motion should be selected before the designing the cam. The cam is assumed to rotate at a constant speed, so it will rotate at the constant speed, that is throughout its motion. So the same speed it will move. And the follower, it may rise, then dwell, then return, and once again to its original position and dwell, with the specified the angle of rotation of the cam during each revolution of the cam. While constructing the cam profile, so I have to draw the displacement diagram before construction of the cam profile. Therefore, construction of displacement diagram is very important. So in the cam follower system, the motion of the follower is very important. Displacement can be plotted against the angular displacement of the cam, that is rise or outward motion, dwell, then the return and dwell. The displacement angle. The displacement of the follower is plotted along the y-axis, that is displacement is the angle of displacement, that is theta. That is ascending angle, dwell, then the descending angle, and the once again dwell. Cam is plotted in the x-axis, and the displacement, the height is plotted in the y-axis. So from the displacement diagram, velocity and acceleration of the follower can be plotted below this. This is the velocity diagram and the acceleration diagram with respect to the ascending, dwell, descending, and the once again dwell. So as you all know, there are four types of follower motions commonly used, that is uniform velocity, simple harmonic motion, uniform acceleration retardation motion, and cycloidal motion. So let's discuss one by one about the construction, the steps to construct the displacement diagram. The first one is uniform velocity. It is a simple one, simple to construct. So always, in the problems, the angle of ascending angle or the outward, the cam follower system, usually the first is ascending, or the cam will move outward, outward it will move, the follower will move outward, then the dwell, then it will return to the original position, and once again dwell. This is a commonly used cam profile. So therefore, for the outward angle will be mentioned, so will be given in the problem, like to design the cam, that is theta O, then the theta D, that is the dwell, then the theta R for return, and once again theta D1 or delta 1, delta 2, that is dwell. For example, 120 degree for ascending, then the 45 degree for the dwell after the ascending, then once again return, it may be the 90, and remaining is a dwell. So therefore, and the height of the displacement, that is, for example, here 30 millimeter is mentioned, that is here height of the displacement. Height of the displacement, total height of the follower motion, it should be mentioned in the y-axis. So therefore, these details will be given. Draw a rectangle of height equal to the follower displacement, that is height, and length of the is equal to the ascending or descending angle. For example, your displacement diagram, this length is not dependent on the cam profile, whereas the height is so important. The actual height should be drawn. For the construction purpose, we can draw, that is because you have to divide the outward displacement as in return displacement in the equally, so you have to divide. Therefore, commonly is So 6 divisions for the outward motion and the return motion. Therefore, so you can take 6 centimeter for the outward, then 2 centimeter the dwell, then return 6 centimeter and dwell. That is, so this outward and return you can divide it into 6 number of equal parts. That is, if you take 6 centimeter, 1 centimeter each, that is 6 divisions, and the return also 6 divisions. Therefore, draw a rectangle of 6 plus 2 plus 6 plus 2, that is totally 8 plus 8, that is 16 millimeter length, and height 30 millimeter, and mark this, that is after the outward 6 centimeter, then the dwell 2 centimeter, 6 centimeter return, and the 6 centimeter dwell. This is the first step. Draw the rectangle of here it is 16 centimeter by 30 centimeter, and divide this into, so that is outward 6 centimeter, dwell 2 centimeter, return 6, and the dwell 2 centimeter. So this length is not important. So only thing is, so this outward and the return should be divided into so 6 equal number of parts, usually even number of parts. Then after this, so in this rectangle, that is, this is outward, dwell, return, and the dwell. In this rectangle, divide the length of the rectangle into equal number of parts. So in this uniform velocity, and most of the cases it is preferably it is 6 divisions, and draw vertical lines through these points. That is, for example, here the outward, so 6 centimeter divided into 6 equal parts, that is 1 centimeter each. So mark the points from 0, 1, 2, 3, 4, 5, 6 in the rectangle, bottom line of the rectangle and the top line of the rectangle. So from these points draw vertical lines, then so mark this 6 divisions. Then once again after dwell, so start from the same point, that is you can start with the 6 only, 6, 7, 8, 9, 10, 11, 12, that is totally 12 divisions. Totally 12 divisions, 6 for the ascending and 6 for the return. That is the second step. First step is a total rectangle. Second step is dividing this rectangle, dividing the ascending and the descending or the return or outward or return motion into 6 number of equal parts. That is, it should be the equal. So that is, these two steps are common for all types of the construction of the displacement diagram. Next is a uniform velocity. In this next it is so this step is specific to the specific displacement pattern. Like join the lower left corner to the top right corner of the rectangle. That is, join 0 to 6 for the ascending. That is 0 to 6. Then so in the that is, it is ascending, then the dwell, then the descending. It will move down to the original position. Once again dwell. Therefore 0 to 6 for the ascending and 6 to 12 for the descending or the return stroke. Then so intersection of this diagonal, whatever you've done, 0, 6, intersection of these this line with the vertical lines are the required points. 1, so mark this. So intersection of this 0, 6 line, inclined line. So with the this 1, 1, it is point 1 dash or the 1. Then 2, 2, it is 2, and 3, 3, it is 3. 4, 4, it is 4. 5, 5, it is 5, and 6. It is nothing but that is, here for example the outward angle is 120 degree. So 120 degree is divided into 6 equal parts. That is 0 to 1 is nothing but, so that is each division is 20 degree each. That is 120 degree by 6. So 20 degrees. For first 20 degree of rotation of the cam, the displacement, for example, if it is a 30 millimeter, here it may be the around 5 millimeter. Then here it may be the 10 millimeter, 15, 20, 25, 30, like this. That is for each 20 degree, this is displacement 1, 1, then 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That is so similarly in the descending also, after attaining the required height, that is moving the required height, then descending, that is after this. So for example, it is 120 degree. After 120 degree, it will reach to the 30 millimeter height. Then so the dwell may be the 40 degree, 45 degree. So in the after this, once again the descending, if it is 90 degree descending, then 90 divided by 6, it is 15 degree each. Here for every 15 degree 5 millimeter decreasing. So that is in the return stroke. So this is the then the mark the points at 1 to 6. Then here it is 7 to 11. So it is a uniform velocity. Okay. Then the simple harmonic motion. The second type of follower motion is the simple harmonic motion. In the simple harmonic motion, draw a rectangle of height. The same thing. The height is equal to the follower displacement, total the height of the displacement. So if it is mentioned 30 mm, they have to draw the 30 mm rectangle height. Then the 40 mm, whatever they given in the problem, length is equal to the asyncronous descending angle like this. Okay, for example here, in this case also same 6 2 6 2, that is totally 16 mm. As outward 12, return. So it is irrespective of the angle. For example, so here it is 90 degree and it is 120 degree. So consider it as the same length, 6 centimeter each, because we are dividing into 6 equal parts. Therefore, so we can easily divide this into equal number of parts. So if it is of 6 centimeter. So then draw the same case like a previous one. Divide this into 6 equal parts. So the first outward motion and the return motion. Then next, in the simple harmonic motion, draw a semicircle. That is this circle. Draw a semicircle. So with the displacement height as a diameter, that is the diameter is equal to the displacement. For example, if it is a displacement height is 30 mm, then the diameter of the circle is 30 mm. The displacement height of the height is diameter. Then so this circle is known as the harmonic circle. Divide this semicircle into equal number of parts. So because since we divided this ascending or descending into the 6 equal parts, therefore so this semicircle also should be divided into 6 parts. That is 180 degree divided by 6 means 30 degree each. That is 30 degree each line. Draw lines, or they divide the circle into 6 equal parts. That is 30 degree, 60, 90, 120, 150 and 180. Then mark the points 1, 2, 3, 4, 5. Okay, this is the next step. Draw a semicircle of height equal to the height of the displacement, or the diameter equal to the height of the displacement. Then divide the circle into 6 equal parts. Then after this, project these points. That is, for example, here 1, 2, 3, 4, 5, 6. Okay, project these points of the semicircle to the corresponding divisions of the Cam-displacement interval. For example, here this line 1, project this, then 2, 3, 4, 5, 6. So 0 and 6 on the same, so in the outer line of the rectangle. So 1 is projected here. Then the intersection of this projected line with respect to 1, 1, it is a point 1. Intersection of the projected point 2 and the vertical line, it is 2, 3, 4, 5, 6. Similarly, so the same thing, it is 1, 2, 3, 4, 5, 6. Then the reverse line 7, 8, 9, 10, 11. Like 7, 8, 9, 10, 11, 12. Okay, this is so these are the points. After marking the points, then join these points with a smooth curve to obtain the required harmonic curve. This is a simple harmonic motions. That is parabolic curve will get, parabolic shape. So that is the simple harmonic motion. Commonly used is a simple harmonic because easy to construct as well as the fabrication, it will be easy. Therefore, commonly used simple harmonic motion. That is also known as SHM. So